Okay, thank you. So we are continuing looking at hypothesis testing. Probably today, the last day of looking
Yes,
at hypothesis testing. Yeah. So as for today, let's look at hypothesis testing again. Maybe I comment. Yeah, let me comment again on hypothesis testing because this is very important. Yeah, you already have ideas about it since we did it last time, but we can still do something about it. Then we will solve some questions afterwards. But let me speak some concepts that you should get. Then afterwards, we'll do some past exam questions, 1 or 2, 3 questions. Then by that time, you'll be fine. You will be fine. We end the class. All right. Just as I said last time, what is involved under hypothesis testing is just to test the validity of some existing statements or postulations that are there set by some researchers or statisticians. So you find that some scholars set those prepositions they propose that what is there is this, and at the same time, since what they say is subjected to scrutiny and the examination whether it is right or is correct or wrong, then what happens is that there is um, a standardized method that is used to examine the validity of those statements that those people speak or those postulations that the scholars propose. So now the standardized method that you use or the techniques that you use to examine is what we call the hypothesis testing. You're testing the hypothesis. I think you have gotten that short introduction. There is the following method. The following is the procedure that you use when you're conducting hypothesis. Number one, you formulate the hypothesis. You formulate the hypothesis. Now, hypothesis formulation simply means that you are just stating the propositions that are there. Number one, you state the existing proposition that you call the null hypothesis. The null hypothesis represented by H naught. So you propose that mu, this one is the population mean. For example, mu is equal to 0, meaning it is equal to that given figure. Okay, it is equal to that given figure. Then the alternative hypothesis will be mu will either be HA is alternative hypothesis. You will say mu is not equal. Okay, we sound this as mu is not equal to what? To 0. Or you can say that mu is less or equal to what? To 0, meaning less or equal to that particular number. Okay, this 0 is representing a certain number, the certain value of the mean. Or mu is greater or equal to what? To 0. Okay, all these are what we call the alternative hypotheses. So now, someone was asking last time that when do you say that this one is a what? It's a double-tailed or a single-tailed? As long as mu is equal. If mu is equal, if H naught or the alternative hypothesis, the mu is equal to the hypothesized value, then that is a double-tailed, which means that the data or the data is distributed symmetrically. That is to say, it can either fall, your postulation can either fall to the right of this center or to the left. That is to say, it can either be a negative value or a what? Or a positive value. It can fall to the right or to the left. That's what it means. But if you find that that's very important to notice, if we find that we say that mu is less or equal to 0, which means that this data is just tilted to the what? Is tilted to the lesser side, that is to the left. Okay, we say that the data set is skewed left, meaning this data is tilted is skewed, or is skewed, this is spelling, is skewed left or to the negative, or is negative skewed in terms of distribution, then that is a single tail. It's a single tail, but to the left. But again, if we say that mu is greater or equal to 0, that is to say this data is on the it's on the right side. What is this? Madam Lenga, we ask that you mute the mic. Hello, Madam Lenga, could you mute the mic for us? Thank you so much. Okay, so this is what it means when you say that the data is distributed to the right, meaning it's skewed right. The skewness of the data to the right, that represents that this data is one-tailed, and this tail is to the right. Okay, that's when you use that one. Okay, you have gotten that one, the meaning of double tail or what, or single tail. So that is to say, for example, okay, we'll see the examples down anyway. So the second procedure is to state the test statistic that you're going to use. So you can either use the Z statistics, that one where Z is equal to X minus X bar minus C mu over what? It is over what? Over the standard deviation, isn't it? It is over the standard deviation. Just how you calculate that Z score. Okay, this is the Z statistics. That's the Z score. So you calculate the Z statistics. You calculate the Z statistics. So when you are testing the hypothesis, it will be over the root of what? Over the root of n. I think that's what we said last time. It should be what we said. So that's how you calculate this one. So are you going to use the Z statistics or not? The Z statistics follows the normal distribution, just as we commented on normal distribution. But when do you know that I'm using the Z statistics or not? Okay. Maybe people can find a challenge. Just a minute. These formulas are just the same. Okay, if you say Z is equal to what? X bar minus mu over the standard deviation, that is divided by the square root of what? Square root of n. It is same as the square root of standard deviation squared over n, like that. You know that standard deviation squared is, this one is the variance, okay? If you square the standard deviation, you get the variance. Then once you square root the variance, you get the what? You get the standard deviation again. So it's basically the same formula. There is nothing much. Yeah. So now you are stating the statistics that you are using. Is it the Z statistics or the T statistics? When do you use the T statistics, and what is the T statistics? That's what we want to talk about. We use the Z statistics when the sample size is at least 30, meaning it is greater than what? It is greater than 30. It is equal to 30 or greater than 30. That's when you use this Z statistics. We'll show you how to make the calculations very soon and quickly. Then the T statistics is used when the sample size is less than 30. Okay, maybe you have 29, 28, 14, any number less than 30, you use the T statistics. How do you calculate for the T statistics as well? As long as you find that this value of n, the sample size is less than 30, you use the T statistics. Okay, the T statistics is calculated as the X bar, which is the mean from the sample, minus the population mean over the standard deviation. The standard deviation, let me use small s, over the square root of what? Of n. This is just the same thing. You know that this denominator, this denominator is just same as the square root of s squared over n. It's just the same thing. Okay. So this is how you calculate the T statistics. Okay. How you calculate for the T statistics. So we'll tell you when to apply the T statistics and how to do that using the examples. Then after you have stated that, the third should be the decision rule that you make. So now, how do you make the decision? You reject the null hypothesis, of which this time around we know the null hypothesis, that it is just that existing statement that you're trying to disprove. So you reject the null hypothesis if the Z critical or the Z value, the Z critique or the T critique, because the decision making in T statistics and Z statistics is just the same. Once the value that you find is greater, once you find that the Z critique or the T critique is greater or equal to what? It is equal to the calculated, it is equal to the calculated Z, or this is the Z of the observations. Okay, I told you, and I'm saying that there are two Z values that we need. We need the Z critique. This is the Z value that comes from the table. Then we also need the other Z that we calculate, this one. This one we calculate it from the information that we are given. Then you are basically comparing these two statistics, this one and this one. That's all what you're doing. Even for T statistics, you have the statistics, the T statistics, the T critique. This is the T statistics, the number that will come from the table. We'll show you how to extract that number. You are comparing with this one that you're going to calculate, which is X bar minus mu over the small standard deviation over the square root of what? N. When the N or the number of population, the sample size is less than 30. So you just basically need these two, and then you compare them in each case. Whether you're using Z or you're using T, you need these two. So what we want to dive into is to show you how you calculate these values. How do you get these statistics? These T statistics and Z statistics, how do you really get them? And how do you compare, or how do you extract those from the table? Because these critics, they come from the table, but these, you calculate them. So how do you go about it? That's what we want you to know. So you always reject the null hypothesis once you find that the Z critique is what is actually greater than that particular value that you're given. And you see in the example that we are just about to do. So that's basically how you make decisions now. Let's quickly do an example. An example will do better. Hello. Hello.
Hello, sir.
Okay. It's fine that we are together. The respondent is tired of responding.
Hello,
Okay,
sir.
Okay. So now here is the example that we are given. Okay. We are told that the scores on an aptitude test required for an entry into a certain job position have the mean. Okay. Which is they have this mean. This is what is existing. We already know that this is our mu. That mu, the existing mean or the mean from the population, is what is called mu, and in this case is what? It's 500. We are told that a standard deviation, it has the standard deviation of what? Of 120. Then there is a sample size. The sample size of what? N. Because they say that a random sample of 36 applicants has a mean of 546. So your question is there any evidence that their mean score is different from the mean that is expected from all applicants? That is the question you have. In short, you're supposed to test the hypothesis that the mean of the absolute test, what they get is 500. We want to test that hypothesis. Does that hold? Is it different or same? Okay, that's the question that we're trying to. So we have our n is 36, that's the sample size. Then what will be our X bar? And you need to know what X bar means. Anyone?
This is a mean.
Anyone?
546.
546. So the X bar is the mean that is coming, yes, from the sample. Okay. You have the two means here, if you have observed. There's a mean that is coming from the population, this 500. We call this as mu. But we also have the mean that is coming from the sample. We call it the X bar. Okay. So we are going to test the hypothesis that this is true or not at 5% significance level. At 5% what? Significance level. So now, how do we do it? Follow nicely. How do we do it? So using the Z-score, because I'm focusing on the Z critique or the Z statistics. We said that we need the two what? We need the two Z's, right? We need the Z that we calculate and the Z that comes from the table. The calculated Z is found as the X bar minus mu over the standard deviation over the square root of what? The square root of n. That's how you calculate for that. That's the formula you use. So what is our X bar? You find that our X bar is what? Is 5 what? 546 minus the mu, which is the population mean, 500. Divided by the standard deviation. Our standard deviation, we said, is 120. 120 divided by the square root of 36, because the sample size is 36. The square root of 36. What do we get as the answer?
20.
We get 20.
Yes,
on top we have 46 over
20.
Over 20.
Yes.
Okay. Yes, over 20. So what is the Z, or what is the Z value? What is the Z from the observations?
2.3.
Sorry?
I guess not.
Okay, 2.30. Okay, 2.3 or 2.30. This is the Z value that you have what? You have calculated, right? Then you also now need another Z that you get from the what? From the table. We call it the Z critique. To visualize, to help you visualize this, this data. We know that since they are saying that the population mean is the 500, meaning this one is a double tail. They are not saying it is less than or is more than. So it means the data is distributed like this. Okay. So when we get the Z critique, we need the Z critique here, the value that will be here, just trying to visualize the standard normal distribution and the Z critique here, right? We know that here after the Z critique, we have alpha over 2. Even this side, we have what? Alpha over 2. Sorry. And what is alpha? We said that alpha, and we are saying that alpha is the significance level that you are given, okay? The significance level is what? Is 5%. The significance level that you're given in the question is 5%. So if it is 5%, 5% is the same as 0.05, isn't it?
Yes.
5% is 0.05. Now, just here, sometimes you might not be given the significance level. they can give you what is called the confidence level. If they give you the confidence level, you know that 100, you know that 100% minus the significant, the confidence level will give you what? Will give you alpha. Okay. You need to get this one. I'm saying that if they don't give you significance level, how do you get the significance level? You're just given the confidence level. The confidence level should be subtracted from 100. Whatever remains is your alpha. Alpha is the same as the what? The significance level. Did you get that?
Yes.
Okay. So now, since this one is a double-tailed, we say that this significance level should be divided by what? By 2. Should be divided by 2. What do we get when you divide that by 2?
Excuse me, sir, before you go ahead.
Yes, madam.
Why in this question is it indicated that our alpha is 0.5? I can't locate the 5%.
Okay, it's here that the significance level is 5%. 5% of significance, that's the significance level.
No, I mean in the question, this
okay.
where
This
putting
was,
isn't this a solution?
okay. This is just the module. This one is just the module. And from the module, what happens is that in the actual question, they give the significance level. So like I'm using the same module that you are using usually with your lecturer. Sometimes, yeah. So I'm using the same module like right now to just pick some concepts that I want to drive before we can go to the questions. I didn't want to just go direct to the questions, but in the actual questions, you find that this is significance level is stated. So it's only that when he was preparing the module, he assumed that you're going to pick it that this is the significance level. Of course, that is the significance level. Did you get that? It is usually specified either significance level or confidence level. Did you get that?
Thank
It
you.
will be
Yes, I
given.
got it.
It will be given to you. You don't need to guess. All right. What do we get when divided by 2? 0. 0 point what?
0.025.
0.02 what? 25. This is the area that is equal to what? To alpha over 2, which is this one, right? This is the area that is equal to that region. The region that is shaded in blue. This region is called our alpha over 2 region.
Excuse
Even
me,
this side we have alpha over 2. Yes, sir.
yes, I just wanted to find out before.
Yes, sir. You can find out, sir.
Going further. I think I lost network. How do you tell that the one we're dealing with?
How do you tell?
That this graph we're dealing with, it's a double-tailed one. I think I lost
okay.
network when we're explaining.
Okay.
Now we tell that it's a double-tailed.
All right. I said that you look at the words that are used around the hypothesized value. Okay, now we are dealing with the mean in the question. They are saying that the score of an aptitude test required an entry into a certain job position have the mean. That is the population mean, the mu. Okay. So if they say that it has the mean of that, it means the mean is equal to what? Is equal to that number. And once you find that the mean is equal to a certain number, then that is a double tail. But sometimes for the single tailed, you can find that the statement would be maybe the mean is less than, okay? The mean is less than 500. You know that that's a single tail, okay? Or maybe they say that the mean is at most. You know that the word at most means less or equal to, isn't it? At most. If they say the mean is at most 500, which means it's less or equal to. If we say that the mean is at least, the word at least means greater or equal to, which means that it is right what? Right-tailed. And you tell that, okay, this is a single tail, but to the right. This is a single tail, but to the left. Or this one is symmetric, is double. Did you get that?
Yes, sir.
Oh, okay. So now we are going to go to the table. That's where you find this area that corresponds to what? To this alpha over 2. We are going to go to the table. This table is usually given in your exam. It's called the standard normal distribution table. You go to the standard normal distribution table and locate this area and locate this area from the table. Once you locate this area from the table, you pick the critical values that define this area. And those two critical values, you form one figure. That's the value that we are going to put where? To put it here and here on the negative side. And we call that as a Z critique. We'll call that as a Z critique. It's a critical value that is coming from the table. How do we get it? Let me move. Let me check now. Let me share. Let me share the what's that? Okay. Okay. Yeah, I want to use the same table that you used during the tests, during your residentials, so that you might not get stuck. You should be conversant with how to use this table. Now, this table that you are seeing, I'm sure you know that this is the table that you are using during the test. This table, it gives the areas that are equivalent to what? To alpha. Get that? That is very important. It just gives the area that is equivalent to alpha. Whatever these areas are here, all these areas, they are representing some significance level, okay? Some certain significance level. And our significance level that we are looking for is what? Alpha over 2, that is our significance level, equal to 0.025, right? That is the significance level that we are looking for now. We have divided it by 2. So we are going to go and look for this area, okay? Look for this area on this table and locate it. Can you locate it? In which line is it?
1.9 and 0.6. 0.06.
1.9 and 0.06. Okay. So how do you write now the critical value? You begin by this one, which is on the cis or this side. The single digit. You say 1.9 plus. There is a certain boy who is slapping people in class.
Oh, sorry.
Okay. 0.06. Hope you are following how we are adding. When you add these two, you get 1.96. Did you get that? I want you to understand how we read these tables so that when you go from here, we can just move forward. Yeah, understand how we read these tables, okay? Sometimes again, if alpha, your significance level, let's say, since I want you to understand, let's say your alpha is equal to 0.5 or 0.05, okay? Meaning you have not divided it, you haven't divided it's single-tailed, okay? When it is single-tailed, you don't divide. So let's look for the alpha, for the critical value. How can we formulate the critical value? You look for this area, okay? You look for this area. You can look for this area. Where do we get it? From this table. Which line is it? Anybody?
I think the closest is
1.5.
1.6.
0.9. Is it 1.6?
And 0.5.
Okay,
1.6 and 0.5.
1.6 and 0.5.
Oh, sorry,
This one
0.4.
or 0.4. Okay,
Yeah.
so it will give us 1.6 plus 0.04. That should give us 1.6 what? 6 for as the critical value. This is the Z critique. Did you get that? Hello?
Sir, just
We are
go back a bit. Sorry.
I go back. Okay.
Mhm.
So we are looking for where we can find this area 0.05 from this table. Where can you locate it? Or and you cannot find maybe sometimes the exact number, but you can get something that is closer, like closer, very close. You get people told us that under 1.6 and what and 0.04, this value is closer to what to 0.5. So that's why we wrote 1.6 plus 0.04. When you added, you got 1.64. Did you get that?
Yes, sir.
Yes, sir.
So
Now,
this
what of 1.6 and 0.2?
1.6 and 0.2. This one,
Yes.
this one is greater than this one. You know, this one is is much higher than 0.5.
Okay,
You've seen,
I see.
we are looking for something that is closer to 0.5.
Okay, sir.
Okay, any other question? So basically that's how you do your alpha. If they say that your significance level is 10%, let's say your alpha is 10%, that is 0.19. 10% is 0.10, isn't it? I'm just trying to give you the different levels of alpha so that you understand how we read. So if it is your significance level is 10% and it is single tailed, right? Meaning you don't divide this if it is single tailed. So it means you just go direct to look for this this area. If you have this table, and I should emphasize that you should first look at the table that you are given. These tables are different. Okay, how you read the values, you read them different according to the table that you are given in an exam. That is very critical, very necessary, and very important. Okay? Yeah, because many people might know what to do, but when it comes to reading the table, they find it a challenge and they end up failing to get the question correct. Okay, so where do we get 0.1?
Just come again on that one.
Which one?
How you tell that you just go direct when you're given this figure like 0.1 and like when you're supposed to divide it into two like you are doing
Okay.
in the previous years. How do you tell?
Okay, I was on the issue of trying to examine how the data is distributed. Yeah, how is the data distributed first? That's where it starts from. If you find, and how do you tell the distribution of data? You look at the hypothesized value. So in this case, we are dealing with the means. The question is dealing with the mean. So you look at the population mean, which is mu. If they say that it is equal to a certain number, in this case, it was said that it was equal to 500, isn't it? Then you know that this is a what? This is a double tailed. Okay, it is distributed like to the both sides. The alternative hypothesis will be mu is not what? Is not equal to 500, which means it can either fall on the right or on the left. But if you find that it is less than that, if they say that the mean is less than or it is at most 500, just know that it is single-tailed distributed to the left. It's less. Then if they say it is greater than that, or they say it is at least means greater than. So those words are very, very important to get. you'll understand that, okay, that means that the data is rightly distributed. Hope that helps. Is the questionnaire fine?
Yes, sir.
Okay. All right. So now let's assume that it is the significance level is 10%, and it is single-tailed. So we are looking for this area, 0.10. Where do we get that area? Anyone to locate it quickly?
1.2. Between 1.2 and 0.8. Is it?
0.8. So you see 1.2, 0.08. We should give us 1.28, right? That would be our critical value to 1.28. Okay. Then again, similar, if you have to divide this by 2 now, we assume that it is double-tailed. You divide it by 2, you get that. Clear? Okay.
Clear.
Let me show you another table for the sake of, just allow me to show you another table which is a little bit different from this. In case you don't have to use, just reading on one table. In case the table is changed, then you can end up getting stuck, but you know what to do. Okay. Standard normal distribution table. Have you seen this one? Here is another one. This one is another one. If you observe now, this one has negative what? Negative values, all right? Hello, listen. This one has what? Negative values. That one had positive. They give the same areas. If you want, it's the same thing. It's only that this one just gives those that are on the negative. Like it looks at those that are on the negative. But if you have been following in my conversations, I've been saying that in most of these conversations, that the right side and the left side is always equal. Okay, so which simply means even if they give you the one that has negatives like this one, you can still use it as if it is that one you are using that has positives. It's one of the tables that you get, this one that has negatives. If you want, you can try out. It gives us the same answers. So the first one that we are looking for, I'll just do one. Alpha was 0.025, isn't it? So we can locate 0.025. Where is it? That side we had found that it was 1.96, right? Let's locate it. So you find it along negative what? 0.025. You've seen it, right? It still gives you the same what? It's only that this one is a negative value now. Negative 1.9 and 0.006. That gives you negative 1.996. Is anyone getting confused? It's the same thing. It's only that this one will give you like on the negative side. However, the negative should not confuse you sometimes. If you are given the z value that is negative and you are given the table that gives you negative values, that is very straightforward. But if you are given the z value, you find the z value that is positive, okay? The z value is positive, the critical value is positive that you are looking for. And you're given this one that gives the negative values, just ignore the negative and you concentrate that alpha is positive. It's the same thing. I don't know if you got that one. If you got that one, then you are safe. You're good to go. That's about this one. Which one is the last one? I've talked about the one that gives to the right. This gives to the left. Has negative values. Okay, let me check for another one. Yeah, the rest of the question is not very difficult, but just teaching you how to read this is what is interesting, and that's what you need in the meantime. Okay. Here is another one now. Observe this one. This one is a little bit different. Is it different? No. It is not different. It is the same one like the one we had. It gives the alphas to the right. Okay. This one gives the alphas to the right. It's the same one, the one we had. Let me check for the one that is different. Where is it? Okay. Statistical tables. Okay, yeah, this one. Yeah. Now observe this one. You've seen the area that it covers. It covers the area, a cumulative area from negative up to the critical values, to the Z value. Okay. It covers all this area from the negative up to this Z value, the critical value. So which means this area is always more than 0.5. It's more than half. Okay. So when you are given a table like this one, if you are given this one, like the table like this one, I used to call it a 4-1. Yeah, it's a cumulative table that covers the area, that provides the area from negative up to more than half to the Z value. How do you use this one? Listen. So number one, you assume that the whole area from here up to here is 100. That's what we know. We know that is 100%. Yeah, it's a 1. In short, it is 1. Let me say it is 1. The area under this curve is equal to 1. Total area is 1. We know that 0.5 is 1. Now, what you do, since this area is greater than 1, you always just have to subtract your alpha, this area which is right to the right of your Z value. And this area that is to the right of your Z value is this alpha, okay? That alpha, the alpha value, the alpha over 2. The alpha over 2, if it is double-tailed, it will be alpha over 2. So you say 1 minus alpha over 2. So how do you do it? Our alpha over 2 from the previous question was what? Was 0.025, isn't it? We had 0.025. So you subtract, you say 1 minus 0.025, which means 1 minus your alpha. Please pay attention. This is one can just make difference. 1 minus that, what do you get? Quickly. That area now, the cumulative area from negative up to, what do you get?
0.975.
0.975. This is the area now that you are looking for. Okay. This is the area now. This is a cumulative area. You've seen it is even greater than what? Half. That's a cumulative area. It accumulates the values from the negative. So you are going to this table now to look for this number. We know that when we use that other table, we were getting 1.6, isn't it? 1.6. So we're going to check where do we find this area? Obvious. It is still in one. It is still the same, giving us the same value, isn't it? It's still 1.9 and the 0.06. That's where we find this area. Okay, and it gives us 196, which is just the same thing again. I've talked about the 3 different tables, the 3 tables, standard normal distribution tables, and you've seen all of them are consistent into giving us the same answer that we are looking for. Any question? You can ask, because it's not a mandate that they always bring that table that you are used to, like maybe it's just the positive or like that. They can bring any of these 3 that I've talked about. They should give you the same answers, so you should know how, or they can give that half one that I was talking about, that one which was half. That one you are very much used about it. Yeah, they are now 4. Okay, you have known that they are 4. -1, the +1, the cumulative, and the half one. So they are 4, but they just give the same answer. Any question? Okay. Back to the concept. So we have known that our critical value is what? 1.6. Our critical value is 1.6. The critical value is 1.6. So how do you test the hypothesis? I've given some, this is the wrong.
Mhm.
120, 148. Okay. Okay. So we were here. We were here. Okay. So this is our table. Our critical value is 1.96, right? Even this side negative 1.96. Here in between we have 0. Okay. Then you compare this. This is called a Z critique, right? You compare this Z with this other Z that you have calculated. You had calculated 2.3. You compare these two numbers. Which one is greater than the other? So you find that this Z calculated one falls to the right of this critical value. Okay, that's how you make a decision. Listen. So once it falls to the right, it means that it falls in the what? In the rejection region. This one is called the rejection region. Rejection region. This one is the fail to rejection region or reject region. That is the acceptance region. Similarly, this side you have the rejection region as well. So that's how you make decisions. Do I have a question on how you make decisions on this one? It's just the same thing. Hello,
Sir,
madam.
me, I just missed the point when you started, like how to collect the data on how to put in the formula. I think you wrapped up so fast, so I don't know which one is a sample, mean, how
Oh,
to read that in the question, yes. But everything else I'm clear, but how to just collect the data, I think once I
okay,
know how to collect the data, it will be easy.
okay. It is given that the aptitude tests of a certain okay, required for entry into a certain job position have a mean of that. So that first mean you find is called the mean from the population. Right? That will be your mu. Okay. So in this case, your 500 will be your mu. This mean which comes from the population. Then you are given the standard deviation. The standard deviation is given as 120. So you already know this one is 120 is given. The sample size is given, the random sample of 36, which is your N. Your N is given as 36. Then when it comes to X bar, this is the mean that comes from where? From the sample. So when they got this sample, they got the mean of what now? 546. That is the X bar. Then you compute. Did you get that?
Okay, sir. Thank you.
Okay. Okay, it's fine. By the way, the class is being recorded, so panic not much. Any other question on how we make decisions? So if you find that this value, this one, if it was less than this one, it means you could have fallen within this region. So you could have failed to do, you could have failed to reject the what? The null hypothesis, right? Meaning you failed to reject if this number, like maybe it was 1.5, it could have fallen in this region. So you could have failed to reject. But this time around, you're rejecting the null hypothesis. Is that clear? That's how we make a decision using
Yeah.
this. Okay. We are fine with the Z. T statistics. Commenting on the T statistics as well, even with the T statistic, oh, it was the same question now. They just assumed that the sample was what? 16. You get, right? We make an assumption that the sample has reduced, it's no longer what? Because we said the T statistics, you use it when the sample size is less than 30. So you just change the sample size to make it what? It was 16. That was just an assumption. Okay, but it is given in the question. If they give you that the sample size, you see that is less than 30, you use the T statistics like this. You calculate the T statistics has given us this value, right? The one that you calculate, the one that is calculated has given us 1.533. This is the one that you calculate. Now you need the T statistics from the table. Pay attention here. We want to teach you now how to read the T statistics table. So you don't go to the standard normal distribution table. No, you go to the T statistics table. That's where you get the T value. But how do you do it? The formula is this one. It is this one. If it is a right-tailed, okay. If it is right-tailed, what you do is you say your T value will be gotten by saying the sample size minus 1. This one we call it the degree of freedom, comma alpha, our significance level, our alpha, okay, our alpha. If it is double-tailed, of course, it will be alpha over what? Over 2. If it is single-tailed, it will be just alpha. Follow nicely. I want you to get on this one. For the T statistics from the table, you get it like this. Is T value n minus 1. This one is called the degree of freedom, okay? The degree of freedom is basically the sample size minus 1. That is called the degree of freedom. So with the degree of freedom, just say sample size minus 1, comma, alpha over 2. Now, what is alpha over 2? Alpha over 2 is basically what? This is your significance level. You know that. So let me show you now from the table how we get these values. From the table, how do you get this value? Where is my table? It's T statistics table. T statistics table. Alpha level. Don't get tired. Yeah, we are not just here to solve the questions and give answers. The idea is just to make you understand. Yeah, so don't worry, we are not slow. We're not slow. Where is it? The statistics. Okay, it should be here. Okay. Here is the table. This is the chi-square table. Anyway, I don't think you have questions from the chi-square table. Here is the T statistics. Okay. Here is the T statistics that you have. It gives you the area that is corresponds to, to alpha as well. Okay. It gives you the area that corresponds to alpha. So listen to this one. How do you get this one now? You just saying, what is the degree of freedom? Our degree of freedom, our T n minus 1, comma, alpha over 2. That is for the double-tailed. Our n is a sample size, which will be 16 minus 1. So it will be 15, comma what? What is our alpha? What was our alpha? Our alpha was 0.5, right? 0.05. You divide that by 2, it will be this one, 0.025.
0.25.
Okay. So in short, 0.025. Aye. 0.025. 15, comma 0.025. This is what you are looking for. This 0.025 is found here. I'm sure, I'm hoping that you are listening. This line on top. That's where you find this alpha. Okay, this one will give you the alphas. This one coming down is giving you the degree of freedom. Okay, so our degree of freedom is 15. So you go to the degree of freedom 15. You see here, right? 15, 0 what? 0.025. So 15, 0.025 is this one. Where do they intersect with 15? What's the value? You've seen it, I?
3286.
2.131, right? Is it? Or I've missed it. Hello?
Yes, it's
Come
the
again.
one.
2.131.
2.131, yes.
Yes. So this is the what? This is the critical value that comes from the what? From the table. And this table is not the normal table now. It's a T statistics table. You just use this one when you are dealing with what? When you are dealing with the, you know that when you're dealing, you always use this one when you're dealing with the sample size that is less than 30. You've gotten that, I think. Any question on how to read the T statistics or the T table? It is just the degree of freedom, comma, alpha, the significance level. If
This
it is
one is
double-tailed,
Come again,
everything
sir.
is easy. It is a degree of freedom, comma, alpha. Degree of freedom, it is sample size minus 1. Then, comma, alpha, you just check if your alpha is double-tailed, you divide by 2i. Then you just check here on top, you find those values are there. So in this case, our sample size was 16. So we said 16 minus 1, 15. So you got 15, right? As a degree of freedom. Then alpha over 2, our alpha was 0.05. We divided that by 2, it gave us 0.025. So you check here on top where there's 0.025. We found it here, right? And 15 is here, the degree of freedom, where the significance level of alpha intersects with the degree of freedom under concern is where you find that critical value. Did you get that? You have gotten that.
Yes, sir.
All right.
Yeah.
Ma,
So provided it was not a double-tailed, it was one-tailed, we could have arrived at 15,0.05, which is 1.753, is it?
exactly. If it was not divided, it could have just been here, right? Yeah,
Okay.
you could have just done alpha alone.
All right.
I think that is clear. That is very much clear. So it just depends on the table that you are dealing with, and that is very important to notice. These tables are very, very straightforward. You have known them now. Yeah, I think even during the test that you had, you were doing the same thing, right? You knew how to do this. If you never knew, don't panic. There is still another chance to do the right thing. Okay. So I think you have seen the difference between the normal and the Z and the T. It's just the decision now. Where is my table? Where is the decision? How do you make this decision? When it comes to the decision is the same. 148 page. How you make the decision, it is in the same way, okay? How you make the decision, it is the same way. How you make the decision is basically the same the same way. So now look at the so here the assumption was what? There check that there was a typing error here. Okay, that's why maybe someone is wondering this value and this one. There was typing error. Have you seen that the sample size is 16, but they have done that 15. They have done 15. You get that, right? So there was just an error, like in terms of typing. So don't panic very much. What we are doing is legal and is not is acceptable. So follow what I have said. All right. So again, when it comes to the issue of making a decision, even in a t-distribution, this value, what value was that? 2.131 will be somewhere here. Okay. Then you will compare it with this one that you have calculated. It will be negative 2.131. You compare it with this one, This one, This one is it falls where? It falls here in the acceptance region, right? It's less.
Yes.
This value is less than that. So you fail to reject the null hypothesis. You just fail to reject the null hypothesis. And you have gotten that, I think. Apart from the T statistics, let me just find out from the class. Did you do the proportions and the put variances? Did you do that?
No.
Okay. Then if the much emphasis was on the Z statistics and the T1, then in the meantime, I think for the purposes of the exam, I think we can just leave it around here. I will not extend my.
How about the t-square? Have we done that? I don't know if it's a t-square or chi-square. Have we done it?
The chi-square. The chi-square. Did you have the questions around the chi-square?
Yeah, he taught on that.
Oh, okay.
Evening, sir.
I did. Yes, sir.
Hello.
Yes, sir.
I just wanted to find out. Is it
May the
possible that
co-host
we
stop
also do
recording?
the what's this